Gravity is a fundamental force of nature that governs the motion of objects with mass or energy. It is one of the four fundamental forces in the universe, along with electromagnetism, the weak nuclear force, and the strong nuclear force. Here's an overview of the science behind gravity. Newton's law of universal gravitation. Isaac Newton first described the force of gravity in his law of universal gravitation, which states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Einstein's theory of general relativity. Albert Einstein's theory of general relativity provides a more comprehensive understanding of gravity by describing it as the curvature of spacetime caused by the presence of mass and energy. According to general relativity, massive objects like planets and stars warp the fabric of spacetime, causing other objects to move along curved paths. This curvature of spacetime is what we perceive as the force of gravity. Gravitational fields. Gravity creates gravitational fields around massive objects, extending outward in all directions. Objects with mass or energy experience the gravitational force exerted by these fields, causing them to accelerate towards the massive object. The strength of the gravitational field decreases with distance from the massive object, following an inverse square law. Effects of gravity. Gravity governs the motion of celestial bodies in the universe, from the orbits of planets around the Sun to the motion of galaxies in the cosmos. It is responsible for holding celestial objects together, forming structures like stars, planets, and galaxies. On Earth, gravity is responsible for phenomena such as the falling of objects, the tides, and the shape of the Earth's surface. Gravitational waves. According to Einstein's theory of general relativity, the acceleration of massive objects can create ripples in the fabric of spacetime called gravitational waves. These waves travel at the speed of light and carry information about the motion of massive objects, such as merging black holes or neutron stars. Quantum gravity. Despite its success in describing gravity on large scales, general relativity is not compatible with quantum mechanics, the theory that describes the behavior of particles on small scales. Physicists are actively researching theories of quantum gravity to reconcile general relativity with quantum mechanics and provide a unified description of all fundamental forces in the universe. In summary, gravity is a fundamental force described by Newton's law of universal gravitation and Einstein's theory of general relativity. It creates gravitational fields that influence the motion of objects with mass or energy, shaping the structure of the universe from the smallest particles to the largest cosmic structures.